So in the previous lecture, I was discussing about how to solve a linear programming problem where a degeneracy has occurred in simplex method. So I told you till the step where you will you find that, or you will recognize that a degeneracy has occurred in the problem or not. So for recognizing the degeneracy, for recognizing the occurrence of degeneracy in the problem, all you need to do is that you have to solve the initial simplex table. You have to come up to the step where you need to encircle the key row, and for encircling the key row, when you will get to see that there are two minimum elements, in the ratio column, then you will get to know that degeneracy has occurred. So whenever you will get to see there are two minimum elements in a ratio column, you will get to know that degeneracy has occurred, as you won't be able to decide which row to be taken as the key row. So for solving this type of problem, all you need to do is that the next step we'll do is dividing S1 by the key column. That is, we'll start with the newly introduced slack variables. So this is the matrix. In this matrix, this is the matrix for newly introduced slack variables. So what we will do when a degeneracy has occurred, the next step is dividing the first column of the slack variable matrix with that of the key column. So S1 divided by X1, it will not always be X1 in each and every question. The X1 or X2 or X3 will depend upon which one is your key column. So it is S1 divided by X1 here. So since we need to take only those elements where the tie has occurred, we will find the ratio for that only, for those elements only. So since there is no tie for the element 3, so we will not find the ratio for this element in the S1 divided by X1 column. Since the tie has occurred between these two elements, so we'll find the ratio for these two elements only. So what is the S1 value for this element? Corresponding S1 value, it is 0, and the corresponding X1 value is 4. So 0 divided by 4 is 0. So we have written 0 here. Similarly, the corresponding S1 value for the third element in the ratio column, it is 0, and the X1 column is the corresponding element in the X1 column is 4. So again 0 divided by 4 is 0. Again we are seeing that a tie has occurred between these two elements and we are unable to decide the key row. So next step is, in the previous step what we did, we divided the first column of the slack variable matrix by the key column, first column of the slack variable matrix by the key column. The next step is, even after finding the ratio of the first column with that of the key column, we are finding a degeneracy, a tie. Again we will move forward and we'll find the ratio of second column of the slack variable with that of the key column. So the next step is S2 divided by X1, that is second column of slack variable matrix divided by the key column elements. So again we'll not find the first element, as this is not a tie element. So the tie has occurred for the second and third element. So we'll finding the second and third elements only for S2 by X1 row. So for this second element, what is the corresponding S2 element? The corresponding S2 element is 1 and the corresponding X1 element is 4. So 1 divided by 4 is equal to 1 divided by 4 is written here in the S2 divided by X1 column. Similarly, for finding the third element, we'll see what is the corresponding S2 row. So what is the corresponding element in the S2 column? So with respect to the third element, the corresponding element in the S2 column is 0, and the corresponding element in the X1 column is 4. So 0 divided by 4 is 0. Now you can see by comparing these two elements, 1 divided by 4 and 0, which is the minimum positive value. The minimum positive value is 0. So the minimum positive value is 0. So we'll encircle the row corresponding to this minimum positive value. So this is our key row. So this was our key column. And what is the key element? Key element is the overlapping of key row and the key column. So from this slide we get to know that X1 is the entering variable and S3 is the leaving variable, and we will proceed further as we used to do in the previous examples also by making iteration table 1, and if the optimal condition is reached, we'll stop there. If the optimal condition is not reached, we'll move forward and we'll make the iteration table 2. So we'll keep on doing the same, we'll keep on forming the iteration tables till we get all the elements of Cj minus Zj row either to be 0 or negative. So this is an assignment for you. I have not completed the problem. I have shown you how to solve the degeneracy problem. So your assignment is to complete the problem as with the same technique we did in the previous examples also. You need to complete the problem, and we'll have a Google Meet session here, and there you need to tell me the answers. So I'm ending this lecture here. Thank you.